Hi guys, welcome to this video. Today is about new tutorials, and we will take a look at optimization tutorials in particular and maybe pick one or two to just play around a little bit with them. This is also because Altair has a new release update 2022.1, and I want to get on track with the newest update, and also just go a little into learning again and seeing what can be improved and stuff like that. So join along. This will be a video which is maybe a little bit longer and also has some twists maybe because yeah, failures happen, so it's not perfectly structured. But on the other side, yeah, I will just maybe cut it if there's something really wrong with it. Alright, so let's go into it. This is Hyperworks, the newest version, and if I click on help, you will see that's the document you get, and there's different tutorials. And we want to concentrate for now on the OptiStruct tutorials. Maybe I will just move myself down here. And now you can see also that you have Hypermesh and Hyperworks tutorials. Let's go with the Hyperworks tutorials. I think those are the new ones, or definitely the newer ones. And then you have linear transient analysis, fatigue analysis, and super elements. Pretty specific stuff, which I did not expect to see here. So with Hypermesh, let's see what's there, because I would want to see more optimization stuff like that, right? So if you see, here's a lot more optimization, for example, topology optimization, right? You see that here, but I think, or I suppose, those are still the old tutorials, right? If you, the basic, everybody does that design concept for a structural C-clip. This will be the old version, right? Well, I mean, it does not change it anything, right? So, yeah, but I think this stays the same. I would say we jump into a new specific topic, right? Let's go with linear transient analysis. Never done that. Well, that's not entirely true, but yeah, you see here also with the naming scheme, you see HWX, and that X, maybe that's a reference to Hyperworks X. It's definitely a newer version than the old Hypermesh, or it's just maybe pre for Hyperworks, could also be. So this tutorial demonstrates how to perform direct transient dynamic analysis using OptiStruct, using an existing finite element model of a wing structure. Alright, Hyperview is used to post-process the deformation characteristics of the wing structure under the transient dynamic load. So what I expect from this tutorial is a lot about tables, I guess, to just also import the dynamic loads and stuff like that, and some card work to have the proper card set up, that it is the right analysis. Let's see how this goes. I think we will start with that. So this tutorial demonstrates, yeah, we have read that. Before you begin, copy the files using this tutorial to your working directory. All right, so you can just do that, and I will just copy that into a temporary folder. Yeah, it's just a single file, so nothing too fancy here. All right, I think, or I suppose, I will just load that file in. So we will have a quick look at it. Okay, I will go with the defaults. It's OptiStruct reader. Yeah, that's okay. Yeah. All right, open. Okay, first things I notice is that it's not shaded. No difference than it is on the help document where you see it's shaded geometry. But that's not a problem. We can fix that here and here. All right, so we see this should be the wing structures. All right, yeah. All right. So let's go back to the help. And I will move myself up again because for Altair you have the panels still in the way. Well, maybe actually, maybe we'll just be very advanced and just hide the panels. Yeah. Should we work with that? So we could work with that exactly. Yeah, maybe. Yeah, all right. No panels. Extra challenge. Okay. So, the wing structure is constrained in all DOF's degree of freedoms at the bold points using rigid elements represented by the rigid 2 component. Transient dynamic pressure load is applied at the grid points in the negative z direction. The time history of the loading is shown in the next figure. The direct transient analysis is run for a total time of 3 seconds, with the time divided into 30 increments, meaning the time step is 0.1. All right, so you see you have a ramp up phase and then you have a constant pressure phase. The following exercises are included. Create a time-dependent dynamic pressure load or the variation of load versus time. So that's table work. Create a time step for transient analysis, card work. Create a direct transient subcase to include the load collectors. Okay, run the direct transient dynamic analysis, post-process the results using Hyper-V. All right, so we launched that, we created a new session, we imported the model, so this is all done. So now we have to create a table D curve. So, and this, I'm very glad that the help is pointing me to the right ribbons already. So it is definitely the new version. If I would ever have trouble finding that stuff which is in the help, I could also use the search function. So for example, let's put it to a test. Table D1. So I could use that. And did that just create that? Let's hit Control Z. Yeah, so it creates it automatically when you just press or search and then press it, right? So let's go the other way. There should be a model ribbon. The model ribbon. And then you should have curves. Yeah. You have curves here, and then it opens a far too large window for you to see, but this is the thing here. And then we add a curve of the plus. So we will name that load history. And yeah, and we want to have the following values. Guess you... Yeah, right here. A little bit hidden. Okay, 0, 0, 1, 0.0.015 and 3. Oops. 0.015. Okay, so ramp up phase and the other phase. Right. I can close the curve editor, so this is fine. And then in the model browser, double click on curves to open the curves browser tab. Yeah, this is step 1. So if I double click here, there comes another browser. Click color and choose a color from the color palette. Okay, I don't like yellow. It's far too bright. Let's go with something darker. For card image, select table D from the drop-down menu. The table D curve that defines the time history of a loading is created. All right, so if that's not set, then you should choose a card image. Table D1. Yeah, because we just created a curve with that menu, it does not have us specify which curve or which type of curve we should create. And so we could have done that with the search a little bit faster, because if you hit table D1, it will exactly do that. So, all right. Now, create a T step. The transient time step defines, let me show that to you again. The transient time step defines time step intervals at which the solution is generated and output. In the model browser, select create load collector. All right, a load collector named time step, and then a color. Yeah, we don't really care about the color for that. For card image, select T step and then T step number 1, and then you have N, which is the number of time steps. DT is the time step increment, and the total time applied is then 30 times this increment. Yeah, so that's easy enough. Let's do that. So back to the model browser, create a load collector. And how should we call that? Called time step. And the card image should be T-step. T-step, all right. Now, 30 times 0.1. Huh. You have to press tab twice to go into the next cell. And yeah, T-step number is 1. That's also good. All right, so we are finished with that. Close. And we could also create a color. Yeah, so you see load collectors, it does not directly show that to you. For such small models, I like to use the following. I think it's still there in application. Huh. It wasn't common. So it was that you have something in a model browser, maybe in browsers. Show entities in model and subsystems browsers. Yeah, this is it. If you check that, see what happens. The browser will get built up new. And now you can see that if you have, what did we just create? A load collector. You can now click here and see the load collector. So you don't have to open 1,000 browsers. So this is a good thing to do for small models. If your models are large, you're happy about the browsers because then you can just filter and do the operations there. So yeah, color, I don't care. That's okay. Now create a pressure load collector. All right. And this should be called pressure, has no card image. And yeah, now I'm interested if we can do that without panels. Let's see. All right, create a load collector. Card pressure. I don't care about the color. Card image is none. That should be automatically. Yeah, that's right. Then I should go to the analyze ribbon. Yeah, we have that. Analyze is here. And then on pressure, I think. It tells me to select the load. But I think it means pressure, right? Yeah. You see, this is a pressure. Is it P-load 4? Yeah, I think that's a distributed pressure. Yeah. So, yeah, you have to be a little bit careful with that. You see that there is different kind of sub-icons here, like before. I know I told that 100 times, but it's in, yeah. Oh, right, okay, it's loads. It's not pressures, it's loads. So I was confused. The other one is forces because it's load, I understand. I don't know why, but I understand the force with a load, and pressure, I have syntactically pressure in my mind if I'm talking about pressures. Yeah, whatever. Okay, so I've that one, and now we should which side? The other one? Oh my god. I have quite a hard time to. Alright, so I have this one. Yeah, this I must say it's pretty neat, this selection method. Yeah, faces, you can see it. Yeah, it's correct. Then we should do 130 p-load. Yeah, p-load 4. Yeah. Change the button from normal to direction. Okay, so you specify a direction. And now I guess it will be the y-axis. No, in z direction. Ah, sure, yeah. So you have a pressure acting in z direction. Okay. Seems a bit odd because it's not normal to it. But yeah, it's just distributed. And I mean, yeah, if you have the wings mounted here with the aircraft fuselage, to push it up here does make sense, right? Okay. Right. All right. Let's create that. We are in the active load collector pressure, so that's correct. So create it here. And now you can see that here. And if you just have a lot of loads, this could slow down your graphic cards or your computer. You could just also turn out the label. And even there's more, which I always am confused where to find that, but to just see, yeah, text and that one. If you just don't have that, maybe that's, I don't know. So the elements I would like to see, but yeah, don't have the IDs and stuff like that. All right, good. Return here, then create a SPC load collector. So another one. Call that SPC, and color is okay. Well, maybe not red because, yeah, let's go something lighter, but that's also not good. Something green, whatever. Yeah, all right. So then what should we do? Load collector for name, enter pressure. I think that's a wrong, right? I think that's a copy paste error. But that's all right. We will just name it SPC. And then color is okay. Then we should go to BCs, so boundary conditions, and then constraints. So we want to hold something in place. And if we just look on the other side, we will see that there are RBA elements which have master nodes, and I guess we will be constrain those nodes in all degrees of freedom. Which is not what entirely correct, because it would have a rotational degree of freedom, but that's just mocking on the high level. So I will just do as the tutorial says me to. I will just select all those 4 times 2 nodes and just click on create, because you have everything checked. That means everything is active and everything is set to 0. That means you have the enforced displacement of 0, which is in case, which is exactly fixed in all DOFs. All right, created those. You will see also the little symbols for the SPCs here. Now we want to have a T load. What is this? And this step creates a transient dynamic response excitation. So not only we have the transient analyzers with dynamics in place, right? We have also the load is changing. So it's not just this ramp up for the pressure, but also there's a dynamic component to excite. But I think this is exactly that one, I think. Because we have now created a pressure. This pressure is static. It does not change over time. But we created also a table D curve. And to link those two together, I think that's where the T load comes into play. So we create now, and this is a new one. It's load step inputs. This used to be load collectors, but it's a load step input now. Load step input, and this is T load 1. No, T load. Should be called T load. And you see this eigen, which is eigenvalue, I think, eigenrelation, whatever. This is the card image it used to be, or the, yeah, eigenvalue stuff, which you also would find as a load collector, but now it's a load step input. All right, T load. And then color, I don't care about the color. I don't think even that we see that. But double click on here. Does not make anything. Maybe because I'm in a panel. And I'm sorry you did not see the 0 values. So I will quickly show that to you. And then away with the panels. So you see here again, this is the card image, and then type, this should be, is that not T load? Yeah, T load name. Let me see. Color. We don't have a color here, and I cannot double click here, so that's strange. And for configs type, select dynamic load time dependent. So this is the first thing. Dynamic load time dependent. And then we have tload1 as a type, which is exactly what we need. For excited, click unspecified and select the 3 dots. So click here, click here. And then I think we should select the pressure, right? Yeah, and apply. Similarly, for the TID field, select the load history curve. Yeah, so you see you have the pressure, which is the load, which is excited by excited. Yeah, it's very exciting. Now it's excited by this table, and you have to just select a curve. In this case, it's the load history curve, and now those two are bound together, right? So you see this ramp up curve we had. This is now acting directly on the pressure value. So it scales it up from 0 to 1. And yeah, so we had also 1 megapascal as a unit. And because the curve has values, this will now become 0.015 megapascals in the high phase. Yeah, so that's it. Now we have that in place, and now we create a load step. Load step, where is it? Load step. And this should be called Transient. Now, definitely we have to change from generic to something more likely. So, Transient. I think direct. Yes. All right. Now we can just assign the different components here, the load collectors, to be more precise. So the pressure, this is wrong. Sorry about that. This should be the SPC collector. So those are the boundary conditions, and then we have the deload, I guess. No, the Tload. Tload? Deload, Tload. Dynamic load, and T stands for, I think, time dependent load. Yeah. So the dynamic load should point to the Tload load collector. Load collector? No, it's not a load collector. It's a load step input. So Tload is to deload, and then we have the time step. I think T-step. Yeah, this time step should point to the time step. What is this? Load collector. No, I'm getting confused. We have time step. This is a load step input. But this Tload, what is the Tload? It's not a table D. Just quickly look again at that. It's maybe the card image, right? Yeah. So this is load step input Tload. Ah, here. Yeah, I have not shown it here. So this is the curve. This is the curve, and this is the parameter set for the time step. Yeah, that makes sense. All right, so we have time step set, we have the load set, we have SPC set. And that's about it. Hopefully. I think so, yeah. Similarly for the TID field, select load history curve. What the hell? Yeah, that's if I'm too excited for going through this tutorial, I'm now a little bit confused. Config type, we did that. Tload, we did that. For excited, click unspecified and select blah blah blah, and then we have pressure. Yeah, we have that. Similarly, for the TID field, we don't have that, right? We have just time step. Yeah, but that's same thing, I guess. There's no TID field here. All right. I was at the wrong thing here. Sorry. Yeah, transient SPC tload, that's done. All right. So the last thing what we want to do is select run control cards, and that's also available here. Analyze, run control cards. Yeah. All right. I will just, for the sake of it, put myself up here that you can see it a little bit better. Now, the famous param card we should get here. So, param. So, now we can think about what that is. PRGPST. PRGPST should be set to no. I have to say I have no clue what this is, but we'll find that out. We'll just search it in the help quickly. GP. So this is Altair SPC. So GP is grid point stress, right? Is it that one? All right, so just that I can show that to you. So PRGPST controls the printing of Altair SPC information to the out file. No Altair SPC data will be printed. I don't know why this is, but maybe because it's a lot of data and we will just want to save space or so. That could be a reason, I think. It's not listed in the tutorial, but yeah. So that's all right. And then another thing is a global output request, which we want to set. So global output request and stress. We want to have some more stress. All right, stress. And we want as a format H3D. So this is the output file, and options set to all, so that we have a little bit more of the stress. Where's the options? Options here. All. So it's, yeah, okay, more stress values. Always good. All right, and then I would think we're done. So similarly, no, we're not done. Similarly, select displacement and SPF and specify the same format and option setting. All right, so it's not just stress, but also SPCF or SPF. SPF. I think I have to look something up again. SPF. I think there's no SPF. So I think that's another error, because SPCF, that's what I would understand, but SPF, I don't know what it is. So SPCF is the constraint forces. It's always good to do that, because if you have those, you can check if your reaction forces are let's say, are the same as your inputted forces, but in the other direction. So format H3D and oh man, okay, option is set to all. Talking about GUIs, I think that should be reworked. I'm sorry, you did not see that, but yeah, you have to trust me that there's some option which I could say, which I could set. So if anyone from Altair is listening, how you set the control cards, that's a pain. That's really a pain. All right, and then displacement. Same thing, displacement, format H3D, and now I will just hide myself a little bit here. Sorry, here. And if I go now to the right, Man, and I cannot click and hold it. Options. Oh, all right. So it's all done here. Maybe, I think there's a better way to do that, but I'm not sure here. If you set the control cards, for example, the global output request, you could also go to the cards. Somewhere here, the card should be. I'm blind again, totally blind. Ah, here, cards. And then you have global output request, and this would be another option to set it, right? So you could say, all right, here, displacement check, and then, yeah, you could, yeah, this is far easier. This is far easier. So I take it back. There's an option to do it without the panels, and maybe that's also a reason why the panels get ditched in the sea. Now, save the file. Let's just save it as that. Yeah, that's all right. Well, maybe I should not save it as FEM, to be fair, but rather as a binary HM file. All right, and then run direct transient analysis. So now we will run the analysis. All right, go to analyze and then on run. And now we're back on the panel again. Okay, hopefully that's still visible. All right, paths are right. I think we'll just run it. Well, let's see. Save as, whatever, all, yeah, okay, no. Optimization? No, actually it's an analysis. So export options all, memory default, yeah, I think. Transient analysis, they don't really require that much of memory, so it's all fine. All right, now 200 megabytes. I think we can live with that. Okay. What? That was pretty fast. Okay. All right, and now the standard thing again, in the help you can see the different files. So we have an HTML report, we have the out file, we have the H3D file, which is the binary for the results. We have the structure with the session and a statistic file for processing stuff. All right. Now we can work with the post-processing. And that's pretty interesting because I have not done that too many times in Hyperworks, but rather I did just open Hyperview basically. And you could also run Hyperview here, but right now we want to do it in Hyperworks. So we have this ribbon post, and then you could go to results. From the results browser, right click in the last timestamp. Maybe should I open some results first? There's nothing here. Actually, maybe you would have to click on Hyperview here. Let's see. But yeah, you have to. So this loads up the results here, and now you can click on the latest time step. So this would be time step 3 seconds, right? And now we go on to the contour, and for the contour you can see this is the standard Hyperview panel you would like to use. And so for example, you just output the displacement and you for sure can animate it. And you also see from the time it bends up and then stays there a little bit. So this is actually the structure having adapted to the load and then staying in that position with a constant pressure. All right, so the tutorial wants us to plot the set direction, and yeah, it's kind of what you would expect. For sure, you could make now some checks on it, which I would encourage you to do. So for example, you just plot, you get a value for the displacement, and then you just approximating the stiffness you would think it has, and then come up with a manual result, and then compare it to the FE result, and then yeah, you see if in a similar category. So in this case, you would, for example, just take the 2 I beams and just use those two. And yeah. All right. Yeah, and we can also plot the stress values for sure. So, but also the SPC forces, you see that here. So this would be rather applicable for a table. So I guess, or let's say we don't want it as a table, but as a vector plot. Yeah, vector plot makes sense for SPC forces, for example. You can see then your SPCs, how they are loaded. And you see that there are opposing directions, which makes sense for the bending load case, right? And yeah, so you can check that here. And I think there's a, yeah, with the query results, you can see that, for example, if you just click on this node, you will see nothing because you did not, or I did not, put in the contour value, I think it's called, or nodal contour, some vector. And yeah, we have a vector, right? So in this case, vector and a resolved system, that's important. So now you can see the components with, yeah, in one line. All right, I think that concludes this tutorial. Was an easy one. I think I'm getting used to the ribbon style. So we did not use the panels too much. In fact, quick takeaway for me is that there is a better way to do control cards than with the panels, and it is in the model browser, and it works actually quite good. Yeah, and keep in mind that you now in the Hyperworks environment here, you have two windows like before. It's opening Hyperview or the Hyperworks version of Hyperview in this environment, and you have to click around with the pages here. So this is still the same as before, which is something good to see. And yeah, so I think I will make a cut here and see what else we can do for the tutorials, and see how to work with different. I'm pretty interested in a design space and design explorer, because I have not taken a look at those features. So stay tuned for future videos about that one. But for the meantime, thanks for watching. If you like it, subscribe to the channel. That helps a lot. If you have any questions, comments, or suggestions what I should include in future videos, just leave a comment or contact me via mail or just on social media. And yeah, I see you around. Bye guys.